right, here we go. Problem number 9, connection between differentiability and continuity. Can someone remind me really quickly? We know, well, we don't know. You guys are hopefully learning that whenever a function is not continuous, a function will not be differentiable. Vocab, what does this mean?
Have it
Able to be derived. So, if a function is not continuous, the derivative will not exist at that point. Okay? And then we have 2 special cases. If a function is continuous, it will always be differentiable. The derivatives will always exist except for these 2 places. Can anyone, in their own words, describe to me why at this sharp point the derivative does not exist? Do you remember?
Because there's no slope. Yeah.
Ah.
The first 2.
The derivative doesn't exist because the slope does not. Sean, go ahead.
2 different slopes.
2 different slopes as you approach. And why is the approach important for a derivative?
Because it's defined
Because
as
it's
a
defined to be. So since as I approach from either side of A, the slopes do not coincide. The slopes, I think I said on Friday, clash, right?
Yeah.
They're going to come together and clash. They're not in agreement, therefore the derivative will not exist. Clash of the slopes instead of clash of the vectors. Anyway. How about this one? Why does the derivative not exist for a vertical tangent?
Is it because at the center point where the slope we're taking the slope on, the slope is undefined, or
Because what kind of line is it?
the tangent line is vertical?
And what is the slope of any vertical line? Just he's reminding all of you. What did he say? The slope is undefined. And specifically, if we want to think about it, this is very much a calculus concept. Isn't the slope getting higher and higher and higher and higher, a higher positive? So maybe it's like 2, and then it's 10, and then it's 50, and then it's 100, then it's 1,000, then it's 1,000,000, then it's a trillion. No, it's going to look inconsequential. They're all going to look straight up and down after a while. But technically, it's off by hundreds, thousands, millions of a decimal in the sense of the steepness, I guess, the grade. So what technically is this slope? What would the derivative look like? Infinity. It would look like infinity. And then the very last one is just a quick little note that says, okay, so therefore, if the derivative exists at a point, if a function is differentiable at a point, what must it be? Because if it's not even continuous, there's not even a chance. But if it's differentiable, or I should say, if it's not, I can't say that either. All differentiable functions are continuous, but not all continuous functions are differentiable. But most are. The only 2 special cases, sharp points and vertical tangent lines. All right, kiddos, on Friday there were 2 pages of examples that we didn't get to. This one I do have solved out in your notes. I'm not even going to have you write this down. This could be something for you to study from or look over as you're playing with homework if you got stuck at all. Question, what am I doing? What are they asking?
Find the derivative.
Find the derivative, and technically, sorry, I had to change it because I didn't type it in. At A. At -1. So there were 2 different ways of going. There were 2 different ways of proceeding. Could I have found f prime of x, gotten an equation in terms of x, and then plugged in -1? Yeah. But what did I do instead? I used one of the alternate forms, which is in the problem-solving strategies forever card, right? Forever number 8. Forever number 8. And I used the one where it says the limit as h approaches 0 of f of a plus h. So it's not x plus h. This should have been an x, but what did I put in the x spot? -1. F of a plus h minus f of a with the -1 plugged in, and move the x all over h. Now, how did I go about solving? What am I doing? What trick? Since it was 0 over 0, keep going. Every difference quotient will always be 0 over 0. I'm simplifying a complex fraction. Why did I not multiply by -1 quantity squared? It's just positive 1, so it didn't really make a difference. I just multiplied by this guy, zoom zoom. Went ahead and simplified top, kept the bottom factor. I went ahead and foiled carefully, hopefully canceled out. Plugged in at the end, once my h is reduced. Did I not even show it? I factored out an h and canceled it. Let's enter. Cheated just a little bit. I went ahead and plugged it in, and the slope was 2 because the negative got squared. So how did I get this guy?
Oh, by the point slope, right?
Exactly, point slope. And what went into the x1 spot?
A. No. Yes. Yes.
What went into the n spot?
2.
Good, so it's the slope of the tangent line. And how on earth did I get y?
Plugged A into the original question.
Plug it in, and negative 1 squared is positive 1, 1 over 1 is 1. Does that look like what I have?
Mhm.
Why did I not go any further? It's not multiple choice, and I'm not making you check it with anything. You don't need to make it match. All you need is something right. So is it right? Stick it to the man. There's no multiple choice, and there's nothing to check, so we'll just stop there. All right. Ready, set, workspace.
Oh.
Ready, set, workspace. Ready, set, workspace, go. I'm going to give you guys a 2-minute head start, and then I'm going to start solving. 2.1 tangent line. I would just call it tangent line example. We could just call it 2.1 walnut, 2.1 open. Remember, draw lines in between each of your workspaces.
Oh, like it knows.
Wow, you're like time now. Oh.
Well, just because I'm letting you like squish it all on pages, I just like them separated. It's good for your brain too to see where different things are. What's up here on the screen is the hint I gave you on Friday. So we looked at this together, how you would do it. And our hint was that this tells us A equals 1. We know the x and we know the y. There's a couple of you to help me get started. You have to find the derivative. You want to find f prime of x with f of x plus h minus f of x all over h, or you want to do an f prime of a? Do you want the one I just did with the f of a plus h minus f of a all over h, or do you want f of x minus f of a all over x minus f of a?
A.
Second one? Oh, that's not one. I'm just writing it for those of you that might have closer notes. This is what we're trying to plug into. Some of you might be going about it different ways, but we should all end up with the same result. So I'm just giving this to those who haven't started yet to have fun. Just go crazy.
Yeah, no. So I'm finding
Because I'm a goof. I use my X. I switched them. I don't know why I didn't.
whoops.
Whoops. When I erased it, I must have switched it. That makes more sense though, yeah, because X is 0, so A is 0.
Okay.
Yay!
So are we not supposed to use the x minus a form first?
You can, I just asked. So people could be doing the f prime of x with the x, f of x plus h1, eventually plugging in 0. They should have the same answer as those of us that are doing this form, and it should be the same answer as the x approaching a. All of them should coincide at the very, very end. Nathan just lobbied strongly for this one, so I just went ahead.
Wow. Yeah, Nathan. Stop.
He's allowed to lobby.
It's kind of a dictatorship. I'm letting it speak.
The world of people was directly translated.
No, I don't think it
I
is.
do consider. I would probably have the
It's
X
not
equation.
direct.
But ultimately,
Yes,
all
it is.
executive
I was gonna
authority
do
has
that.
on Misty.
Huh?
We haven't done one on the board.
I know the other one.
I mean, if Misty wanted 6-3 to be due tomorrow, she could.
So anyway, how's that simplifying going? You guys, how you cube 0 plus h?
I gave up simplifying a long time ago.
Why did you give up simplifying?
Because it's
I
disgusting.
think I'm doing it right, but also.
It's technically, Sarah, it's technically easier the other way. The f of x minus f of a.
Is it?
So I am doing it.
Because you don't have to cube 0 plus h.
Wait.
Well, I mean, the cubes are, isn't it?
Yeah, it's not too bad. You can use Pascal's triangle. Remember the 1, 3, 1?
Wait,
Yeah,
why?
that was.
Oh, wait.
Why is it not just 8 cubes? I'm so confused.
Oh, so I put in.
But it's zero.
But
That's
it's-
fine. Oh wait.
I'm so confused.
Wait a minute, what's 0 plus
Why
h?
is it?
Yeah.
I know, why isn't it just 8 cubes?
I was having too much fun, but then I figured out you guys were all stressing, so I was like, alright, never mind. H cubed minus 0 plus h is h. I stopped having fun. I stopped having fun.
I miss me so much.
Come on, there were a few of you that were like, oh, actually, I think this is
Yeah.
right? I could have had fun for a little bit longer, but somebody spoiled it. Alright. Now I can pull out an H.
I didn't know how to. I don't know how to do it yet. I never liked it. But it's easier when I.
Plug it in, plug it in. 0 minus 2 is negative 2. They're still walking in the back, I think they got it. Was our objective to find the derivative?
No.
No, that was one of the steps of the process. What's our objective?
Find the equation.
Equation of the tangent line. So what does your brain need to jump to?
Y equals.
Good, y minus, just write it. Just write it, and then be like, alright, how do I plug in? Good, m is negative 2, the slope of the tangent line. Now I just need a point.
One.
Y minus 1 and x minus. Can you box it? Yes. Did you get there?
Well, I'm still thinking it's actually.
Okay, now what is it talking about when it says graph both on the same screen? Both what?
The direction and the other slope.
Not the derivative,
Oh
the
wait, no.
Both functions.
function and the tangent line. So I'm going to go ahead and do that quickly. The function and the tangent line. If all went well, if we found the right tangent line, shouldn't it skim the graph at 0, 1? So we're really just checking. It should skim the graph. The graph. I don't know where I was going with that. It should skim the graph at 0, 1. So we're going to throw in the function to y1. We're going to throw in the tangent line to y2. Now, in order to throw in the tangent line, what do I need to do? I can't throw it in like this.
To y equals mx.
Okay, so I am going to have to make it into y equals mx plus b just by context of needing to graph it. So I'm going to do the function, I'm going to go to y equals, we're going to go ahead and do x cubed minus 2x plus 1.
Yes.
And what's my y equals?
That's not wild.
Crazy.
Look at that. She's nice.
What? Is that a good thing or a bad thing?
That's
Well,
bad.
if we zoomed in, I imagine it would look a little better.
Where's 0, 1? Question, is it skimming at 0, 1? Yeah? So here's a crazy thing. Can a tangent line cross through a graph?
Yeah.
Yes. Now the weird thing is it really is only touching at one point. Just the weird thing is it's on top of this portion and it's on bottom of this portion. Here's a really interesting math
It's a
thing for
point
you
of
guys to know.
inflection.
The tangent line will always be above a concave down portion. It will always be below a concave up portion, but it's still skimming at the point 0, 1, so it's perfect. That's exactly what we needed it to be.
Wait, what?
It's still skimming.
Magic.
It's still skimming. It's weird in your brain because it's above 1 second and below the next. It does cross through.
Oh, so that's
But it crosses through in a way that it skims the graph.
But that's not the thing. That's
But it skims and crosses through only at one point, which is the definition of a tangent line. And the weird thing is, what if this was a quartic, and what if it did something like this? Is it still a tangent line at 0, 1?
Yes.
Yes! But it might hit. Well, pretend it hit. I just didn't have room. It would hit somewhere, but it doesn't matter. Is it skimming where it needs to skim? Yes. Some of you are just stuck in the definition of tangent line from geometry where you were only dealing with circles. We're not dealing with circles anymore, cool kid. So a tangent line skims the graph at the point of tangency. Check. Dun, 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 dun. Because what other slope would it have right there? That slope. Okay. Mind blown. Sean's still processing. Tyler.
So sick. No, I'm mind blown at how you just dragged it out of the calculator.
I did it last year. You were so funny.
so many times.
Yeah, Tyler, what's up?
So are there multiple tangent lines, but there's only one that reflects the slope of the graph at the point?
Multiple tangent lines.
Because you could draw other lines that only cross that graph at one point, yeah.
At that point?
Or at that point too.
Well, a tangent line skims. So any other, like, I see what you're saying. You're like, I could draw anything that only crosses through that one point for that one local region. But the tangent line, the skimming idea still needs to be true. And the skimming idea is basically just a simplified geometric, like when you were in 8th or 9th grade, way of talking about the slope at that point. So, yeah, there's only one that truly skims. We're done. Homework we're going to check tomorrow. You guys are going to see in homework that whole sketch the graph of the derivative of the function thing about. Did we talk about this on Friday?
Yeah. Well, it was the workspace, but
Okay.
we
We did.
just looking at one.
We looked at one. Okay.
It was really hard.
It's a hard homework problem. So I don't know if you guys get to that homework problem on 2.1. Do the best you can. If you have an educated guess, go for it. But otherwise, just draw the 4 graphs I think that you're asked to do, or maybe not asked for 4. Just draw the graphs and wait. In homework 2.1, Nathan, do you have it? It was the problem where it says, here's the graph of the original, sketch the graph of the derivative. He was in the 20s.
And
it was
37,
37, 38, 39.
Okay, so for 37 through 40, whenever you get to the sketch the graph of the derivative, if you're lost, if you're stuck, just draw the original graph, and then tomorrow when we grade in colored pen, you can compare the original to the derivative, and we'll talk through how to get it. Does that sound good? You don't need to skip any lines or anything, just draw the original graph and be ready tomorrow, if you don't know what to do. Alright, cool kids, here we go. Section 2.2a. Now, for those of you guys okay, for those of you guys that, I know it was very exciting. For those of you guys that did fully attend 2.1 for today, you're going to be so excited that we got to 2.2a. Because basic differentiation, this sounds a little bit like differentiating, deriving a different way than the definition. 2.1 says, hey, there's a definition. A derivative is actually a limit. And it's super important for ideas like differentiability and sharp points and vertical tangents. And it's super important for certain types of calculus AP problems that might come to understand how the limit definition applies to the derivative. And maybe even how to solve. But we don't stop there. We say there are shortcut rules.
So should 2.2a be its own thing?
It's its own section and it has its own homework. Yeah, 2.2. I split up 2.2, I think also 2.3. And yes, there's a chapter test on chapter 2a. This week? I don't think it's this week. I don't think it's this week. You guys are focused on practicing derivatives this week by definition and shortcut rules, and you're focusing on test corrections for Wednesday.
When's it for?
Day before the test. I think it's next week or maybe even the week after. I'm going to freeze the screen really quickly just to look at our calendar. I had it all the way updated to the next test, I'm pretty sure. So I was working on it yesterday. Remember, guys, with corrections, you can work on it 0 period Wednesday, you can work on it after schools, lunchtimes, any day but today. Remember, today is my student council meeting. Oh, we're good. We don't have a test for another couple weeks.
What the heck?
Did we ever fix the textbook thing?
The textbook thing.
Oh, stink. That's what I was supposed to do this weekend. Did anybody actually check it? Remember you were going to check it that night and see if it didn't work? Alright, I have to call them. I have something to do during my free period. I have a meeting during lunch. Nutrition, I'll probably run to the restroom. Won't be time to call. After school today. I'm going to put that on. I have our next test as being Tuesday, October 3rd. Because we have, now listen really quickly, it's only sections 2.1 to 2.4. But I split 2.2 and 2.3 and 2.4. No. 2.2 and 2.4 into multiple sections. Because our book covers them a little bit too quickly.
What's the next slide after this one, Steve?
Alright. Alright. We are going to go ahead and, just for point of reference, there is a calculus controversy video. Did we watch it last year? I don't think we had time.
No.
We were rushing to them. We got behind. We're going to watch the calculus controversy tomorrow. It's some of the history behind the calculus. It's super interesting. Just gives you guys a point of reference as to where the calculus came from. Just a little bit. There were two different guys. There was this whole thing as to who was actually the actual founder and discoverer of calculus. But anyway, we'll watch that tomorrow because I want you guys to at least today get to see the rules. Get a forever card down, and then we get to play just a little bit. And then tomorrow we'll watch the calculus controversy, and we will just play with a couple different types of examples. So the nice thing is there's not a lot of notes, guys. This is the big page. This is the wordy page. The rest is, hey, here are some formulas, and let's learn how to use them. Anybody still writing this down? Okay. So if you want to put in parentheses, calculus controversy, but then let's get these rules down. This is the beginning of the basic derivative shortcut rules. This is the beginning of the basic derivative shortcut rules, not the definition. The definition is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta equals prime of x. That's the definition. These are the shortcut rules. You guys remember the verb notation for to derive?
Differentiate?
No, the notation. Yeah, d over dx. Good. So. I'll go ahead and move these over to the side just to make them all nice and neat. So dvx means to derive or to take the derivative of, right? So the derivative of any constant.
0.
0. Once we talk about the power rule in the next one, I'll tell you why. And I already kind of have. I didn't teach it, I just showed. The derivative of x to the n.
Is n x to the n minus 1.
You guys tell that Tyler's very excited. N x to the n minus 1. Constant multiple. Basically, what if there's a coefficient? Let's not do that. That's a little too much. I'd rather do this. does A stand for? Coefficient. So the derivative of 2f of x is 2 times f prime. So this means that I'm just saying constant multiple. Whenever there's a coefficient and you're taking the derivative, the coefficient stays and take the derivative of the other piece. Sum and difference says if I'm taking the derivative of one function plus another, or maybe one term plus another, one polynomial term, one power plus a different. All I'm going to do is take the derivative one at a time. I keep the addition, and technically I can keep the subtraction too. So if it's f plus g, I'm taking a derivative, no big deal. Take the derivative of f plus take the derivative of g. Which is kind of like a limit property that we wrote down once upon a time. Because the limit is the other limit properties with products and quotients do not, and compositions do not apply. Sine and cosine, here's an important one. Wrong one. The derivative of sine is cosine. And the derivative of cosine is negative sine. And last but not least, I can show you, just hold on. Have some faith. Last but not least, I'm just going to do the basic exponential function. We're just going to do e for right now. There are other exponential functions, but believe me when I say we're just going to do e.
Mrs. D, if you were to get every exponential question wrong on the AP exam, could you still pass?
It's the easiest one.
I know, but
Yes, you could still pass with flying colors and with a 5. But there's even like a really snazzy math quote from Francois de Lyonnais. He said, "Who has not been amazed to discover that the derivative of e to the x, like a phoenix rising again from its own ashes." Ooh, I just said it wrong. Who has not been amazed to discover that, like a phoenix rising again from its own ashes, e to the x is its own derivative. Something like that. It was on someone. Whose sweatshirt was it on? Oh, Lauren Gear's older sister, Julie Gear. She drew like a phoenix, and it was on the back of the sweatshirt, and we had the phrase. And this whole thing. This is rubber number 10.
Oh, it's beautiful.
It's not extra. It is the most beautiful derivative formula.
Well, because why? How three stuff?
No, you guys will see where it comes from. You just can't see it yet.
It's rather silly.
It's not fun.
You guys can do what? 1, 2, 3, 4. You can split it in half and do these 4 and then those 3. You guys can fit it all on. You have enough lines on one forever card. Wimps. Anyway. Here we go.
I used the non-levels.
You guys ready? The directions are, find dy dx. Dy dx represents what?
The derivative.
The derivative. You can also say find f prime of x, but we usually only say f prime when the function notation is f of x. With y, we usually use dy dx. These two go together, and f of x and f prime of x go together. So on this one, I'm going to do it step by step. I'm going to do it step by step. The constant multiple rule says if I have negative 3 times a function, I keep the negative 3 and I take the derivative of the inside. Look up above, constant multiple rule. There's a coefficient in front. A is negative 3. I keep the negative 3 and then I take the derivative of what follows. So how do I take the derivative of x to the 12th? What rule?
Power.
Power rule. Power rule says n comes down, x stays, and what happens to the power? Decreases by 1. So dy dx does end up equaling negative 36 x to the 11th. What two rules did we use? Constant multiple and power. We have the rationale, the reason for why we did what we did. Now, the AP will never ask you the rationale for taking this derivative. They will assume that you know how to do this in a split second, eventually. But, do you follow the logic of what I did? Negative 3 is a constant multiple, so I keep the negative 3, take the derivative using the power rule. Dun, 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 dun. Question. Is that a lot easier than
Yes.
pause? Pause. What would I have to do if... Man! Would it be a party?
Unless x is 0, then it's a nightmare problem.
Yeah, because we're not doing at a point, we're doing the general function. So what will we have to do in order to simplify? It's 12 power. Now, could we eventually get there with Pascal's and have a lot of fun getting there? Yeah, we just need to get down to 12. And then we would have 13 terms to write out, and then we'd run out of paper. Is it possible? Yes. Should I make it a bonus on something? That would be fun. But
I'm not doing that.
I'm hungry for points. There's 12 points.
let's go. All right.
I'm
Hold on. There's only so much time left. We have to have a little bit more fun. How would you take the derivative of the following?
Distribute.
Okay, so we have a constant
Two
on
ways.
the outside, so it would just be 1 half.
One way is constant multiple. You could just keep the one
And
half.
then power the x to the 4th and constant the 7th.
Because sum and difference property says I can do them one at a time if I'm adding. So I would do power rule with the first. Sum and difference says plus. You guys see how I decreased by 1, right? 4 minus 1 is 2. And then you can either think of this, ready? Where does the constant rule come from? Yes, the derivative is just 0, but think of it as x to the 0. Doesn't the 0 come down and cancel everybody out?
Yeah.
Whichever way makes more sense in your brain. The derivative of any constant will always be 0. If you want to think about it, it's x to the 0 comes down. Okay, end up with 2x cubed. Now, Tyler, how did you say we could have started in steps?
Oh, just distribute it and then bring down the 4, and it's 4 over 2 times x to the 4 minus 1, which is 2x.
Bring the 4 down.
It's too complicated.
Good question. Would it have worked?
Yes.
So as long as you do legal math steps, you should get to the same derivative either.
Why isn't
Oh, because I added it. The derivative of any constant is 0, and I said because the power is 0. Does that make sense?
What are you saying?
So, we're going to ask you for, last one for today, find dy dx, and, what are we on, example number 3? Y is equal to question, can I use the constant multiple rule? Yes and no. I can with the 3, but what can I not use the constant multiple rule with? The x squared. So we would have to use Tyler's trick. If we want to leave the 3, we could, but we would have to get the x squared in first. And at that point, wouldn't it maybe be easier just to throw the 3 in also?
Yeah.
So I'm just going to throw the 3 in. Because the constant multiple rule is illegal to use if there's anything more than a constant. Have you guys taken the derivative yet?
cool.
I just wrote 2 different forms. Done, once you have it down. Bye. See you later.
What? Bell rang! Oh my god!
2.1! You have to use the definition. 2.2. Ooh, that's gonna be fun. Get through 2.1 for tomorrow. 2.2, if you want, you can start and have some fun with it. But we have much more to learn.
So Steve, when are we learning the other rules so that I don't have to do
Bring
work?
the 3 down. 3 times 3.
This is
Don't worry, we'll look more this month.
What?
Oh, I said we'll look more.
Definition.
Don't worry, there's harder, trickier ones.
Not really. Not for a while.
Right here, it gets tricky.
Yeah, English here.
Bye, everybody. Thank you. You're welcome.
That's on us. I thought you, like you said.